In this video, we'll have a look at how to operate on an example dataset which is given as an array. So for this purpose, I'll actually try to use some data available within MATLAB, and it has a bunch of data sets which you can load directly without having to look for it in the folders. How to find such data sets? It's enough if you put in Google sample data sets MATLAB, for instance, and then you should find a link to MathWorks website where the list is given with some small explanations what the sets have. Okay, and I decided to use this one file which I have worked with before, and it contains both a matrix and a cell array, so we can have a look at some challenges which come when you work with such data. So all you have to do once you pick one of those, you just load it by giving the name. So I know this one is called Fisher Iris. You don't have to put .mat because it's a data file that MATLAB recognizes since it's its own. So let's run this portion and see what is inside. So there's a matrix called MES for measurements and a cell array called species. And we can see that the number of rows in both are respective, so most likely the species have respective names of the species for each row of our measurement matrix. Just to make sure, why not seeing what the data actually contains? It's not huge, it's just 150 rows, 4 columns, and here is 1 column. So yeah, the measurement data has the values in here. And then the species, let's try. Yes, so it seems like there are 3 different species. They are actually organized or arranged already in the way they are there. Now, as the first step, I would like to split my measurement matrix into 3 separate ones which have data for the respective species. So I will want to create matrix, let's say CV and V for short for the 3 species. So my first thinking is that, for instance, for the first one, I would pick from my measurement matrix those rows where species equals that first name and all the columns. So this would mean that this portion should show us where in our cell array, in which rows of our cell array we have that name. Well, let's check if it works. So I first take just that small portion and see whether I actually get what I want. Okay, and MATLAB actually tells us that this operator for comparison is not correct when we work with cell array data. Okay, let's let's see what happens if we pick a particular element of our cell array and try to compare. Yeah, now it works. So it's not capable of comparing the whole cell array at once, but it can compare those one by one. So that's a hint for us that we might actually handle it within a loop. And that would mean that within a loop, we visit every row of our species cell array, and we compare that with specific name that we are interested in. And if that name fits the name in that row, then we pick that respective row of our measurement matrix to the specific array. Okay, so Okay, so let's get those, let's get it done. So we need a loop which will be visiting our species rows. And that means that loop has to make as many steps as many rows there are. So we can tell the loop to walk from 1 up to length of species. So now length of species, again, let's check first here. This should give us 1/5, and that's correct. And so now within that loop, we will have some if-else condition. So now we will want to create 3 arrays for the 3 species, and I will prepare them empty. And V was the last one. And let's also put those names here. And what the names are, I can actually get out from my species array using function unique. Unique for a given array finds unique values that appear in that array. So for instance, if I use it now, even though it's a cell array, that still works, and it lists for us those unique strings which are there. So we don't have to type them manually in here. So now I will tell MATLAB that if for that particular row the value of the species, so the name of the species, is the same as the first one in my names, so I will want the respective row of my measurement matrix to be placed in that array SE. So I will say that SE will become what it used to be up to now, and in a new row, we can even make it like this to make it look more natural. We say that from the measurement matrix, we pick that very row that we have found to be having that name we are interested in. This could have also been written in the same row with a semicolon. Remember, semicolon is the one which places what comes after it into the new row of an array. Okay? Then, else if our species is not having the first name but second one, then I know that I want that respective row of measurement matrix to be placed in my second array, which is VE. So again, I say that the new value of VE will be what it used to be, and then that respective row of my measurement matrix. And finally, since I have only 3 cases, I can use else without having to type else if species I equals names 3. I don't need it, I just say else. So in any other case, place it in that last array. So now I end my if and end my for. So when we run this code, we should get a result. Not yet. Let's see what's the problem now. Matrix exceeds array. Let's see. Is the problem actually here? All right, we get an error. And now I know the reason. The reason is that when we are doing this comparison, species I with names 1, for instance, or any other case in here, we are actually comparing two strings, two text arrays. And we have seen that the names in those are actually not equal length. They are all three are different. So now my guess is that I has reached a place where the actual species I is the second name, but it's trying to compare it now with this first one, which is shorter. So there is a mismatch in here. So if I check I for species of I, we will get that second name, and the previous one I'm sure is still, yes, the first one. So that's where we hit the problem. So let's think how to go around it. What we could have done is use the car function. Let's see if we use that on our names array. If you remember this car function, it combines characters into equally long strings where in case some original string is shorter, that missing space is filled up with spaces. So now you see all the three characters are actually same length. So that makes the comparison possible. And that also means that we would have to do the same thing on the species array. So that might actually resolve our original problem where we were not able to compare directly the species with a specific value. Well, let's call this with small lowercase n, and then my names now will be car of names, and I'll do the same thing with species. So when we run these two, we will get actually text arrays, which are like matrices. And in that way, we should be able to actually compare a specific row of species matrix with a particular row of names matrix or array. So let's try again here. Now we will try species equal names, and now note that I have to point that I want MATLAB to compare that with specific row of names array. So this names with capital N is not cell array anymore. It's actually a text array like this. So yes, what happens now? Let's see. So what it does is it actually compares, yes, now it compares the characters, which means that for instance here the second letter of these names was the same, so that's why there is one here, and in here the last character was the same, but it actually doesn't stop us from using it in if else. So now the thing is that if you have in such a comparison all ones, so all true for comparison of two strings, then if you use it as a conditional statement, it will consider the whole array true only when all are ones. So now it means that in here I can use comparison of those strings in here. So instead of species I will have capital species, and it's not a cell array anymore, but an array with rows and columns. So I am picking specific row of that array and all columns of it, and I compare with I compare with the name I'm trying to pick, so in this case it's the first one. Now when we do comparison like this, MATLAB will actually compare two strings. Let's do it like this. If we have species first row, compare with names first row. So here it compares them character by character. And when such a comparison is part of if statement, it means that MATLAB will consider this entire thing true only when all of these are true. So it will really not consider if, for instance, somewhere incidentally some two characters are the same but not all. And the example here is, for instance, if you compare it now with the second name, you see somewhere on the way one letter is actually the same, but it's not enough for us to say that it's the same name, right? Okay, so let's now copy this into the other place. So this was the second name, and finally again the last one can just remain as else. So let's run it. Now it ran without errors. And let's see what are the contents. So we have SE, VI, and VE. They are all now separate. We can check the lengths. It's 50, so the first 50 were that. Then the length of VE is also 50, and VI should be 50 as well. So you can see sometimes as you code something, you may come across trouble, like I did in here, but I did it on purpose so that you can see through thinking and through going around the problems, you can still achieve the goal that you're trying to make. And now, for instance, if I look at a particular array, so for instance, in my SE, I would like to know the mean values of all those, whatever properties are in the different columns. So I just say mean SE. This will give me a row vector with 4 values because that matrix has 4 columns. And for instance, now I would like to pick from my SE array only those rows which have the first property, for instance, below the mean value. So what I do, I will say that, I'll call that maybe just X, and say that I want those elements of SE array that were the first row, first column values are smaller than the mean of the first column. And then I want all columns of that. So you see, what will happen is that MATLAB will go through all the rows. It will check whether in that particular row, that element in the first column is smaller than the mean value of that respective column. And if it is, it will keep it on the list. So when I run this one, I should get X array should have less elements, less rows than our SE matrix. Let's try it. It seems to have less than 50. Let's check. Sorry, not length 50, of course, length of X. So you see it's 28. And now conditions like that you can combine. So for instance, you want rows where the first property is below average, but for instance at the same time you want the third property to be above or also below the average of that property. So if I take third column, I want to compare it with the third mean in here, and I combine it with AND because I want those two conditions to be true at the same time. Let's see how many we get. $17. So before there was 28. Now we added an extra condition, and it turns out that that limits the number of rows that satisfy that particular condition. And you could keep doing that in whatever combination you would like, and on whichever matrix of those three that you like, or maybe on the whole measurement matrix. It's up to you, but it just shows you how this logical indexing on the matrix works. You always have to remember whether you're referring to rows or columns and keep them separated with a comma. And so, for instance, when you define a limited number of rows by some condition, remember to keep then the semicolon if you want to take all the columns from your data. But I could have also asked now to take only exactly that first and third column. So adding something like that is also possible. It is always all dependent on the job you're actually trying to do with your data set, but anything is possible.